Well, welcome. Thank you everyone for coming to this little tech talk that I've prepared. Nobody really knows what I'm going to do with you today, so stay tuned, stay pumped. I have thought about what I could talk about when Christian asked me if I wanted to talk about materials a little bit. And of course, the first thing that comes to mind is, yeah, let's build the perfect and best master material you have ever seen that is photoreal and all that stuff, blah, blah, blah. But I thought I'd take a different approach, and what this looks like, I will show you now.
In a world out of control, where humanity has failed to take the necessary steps to avoid the climate disaster, one drone has the power to bring nature back to its former glory. Drone seeds for forsaken lands, available nowhere.
Right.
Let someone say again that I am crazy.
Right. So welcome to Drone Seeds. Just a few words about me for those of you who do not know me, because not all of you I have trained. So my name is Stephan. I'm a digital content creator. I'm also a freelance 3D artist, Unreal Engine generalist, and all that stuff. Not that important for now. That's why I will skip this. You will get this presentation afterwards if you want to. All right, to start, I would like to give you a quick project overview, what I have created and what we will try to recreate during this course. This is more of a tech talk, as I said before, so feel free to follow along if you want to. If you don't want to, you can just lay back and listen and watch while I'm rambling about here. I have prepared a few files for you, so if you want to follow along, let me see if those are the correct ones. Yes, I'm going to give you a link now in the Zoom chat. This is just 1 or 2 megabytes, so you should be able to download this. It's not 50 gigabytes. And these are just some static meshes that I have prepared, so you can use them in the same way I have done so in my project. Also, feel free to just create an empty Unreal Engine 5 project if you want to follow along. There will be a little bit of time until we get to the engine part, so take your time with this. Quick word on the agenda. I will give you a quick project overview, as I've said. Then I will talk about world position offset basics, which is the material function, material part that we will cover today mostly. Also, I will talk about procedural masks a little bit that I have used. And then we will start with the follow along part, where I will give you a few material examples that I have prepared, and we will recreate part of them. After this, I will give you a quick preview of the next talk that will happen next month, which will also be part of this project. And afterwards, if we still have time, we will start a quick question and answer session so we can gather feedback and just answer some questions. All right. So please keep your questions if you have them with you until the end, and then there will be a special time slot for that. There we have it, Drone Seeds Forsaken Lands, the game that never was and never will be. This was just a quick idea of me where I could implement some of the features I wanted to showcase in some sort of like full project that also might be interesting to follow along and rebuild for yourself. So this is a little game project, a single player game where you fly a drone and you shoot seeds into the ground to reforest the world that has been driven to shit by humanity. You have multiple types of trees, and we can build up the material part of this in this talk, or at least take a look at this. And afterwards, I will give you a project download where you can download the materials in full that I have prepared for this. And in the next Tech Talk in October, maybe we will take a look at something else concerning games. Let's start with world position offset basics. What is this? What can you do with it? So world position offset is just inside of our material output node, just one input that we can put something in. I assume that all of you have seen the material editor before inside of Unreal because all of you have been trained by Incas. So I assume you know at least your basic material stuff. I won't start with the real basics. With world position offset, you can handle vertex manipulation inside of a material. These vertex manipulations can be chained together for additive effects. That's also possible. You are not bound to only one function, one effect. It is calculated on the GPU, and the original position of the geometry doesn't change, as you see here in the screenshot down below. This is also the first basic material that we will build, just so you get a sense for what it does. You can use either predefined functions or build your own. So inside of the material graph, there are some functions that I've also used for some of the material examples. But our first material, as you see, is this one, which is rather basic. You can also build this for yourself. A few advantages and disadvantages of using world position offset, because for some of you, I understand this might be completely new or something they have never heard about. And right now you're probably thinking, what am I looking at? The world position offset is really powerful for special kinds of use cases. So the advantages are it's highly performance optimized since it runs completely on the GPU. It offers easily handling with material parameters. So if you know materials and your parameters, you can build up some really cool effects using world position offsets and don't have to touch a blueprint at all, for example. The vertex displacement that you can do with this could also otherwise only be possible with geometry cache. So for example, you can go even 2 or 3 steps further than we will go today and create some like water displacement or bake animation data into textures and use this on a static mesh instead of a skeletal mesh for a character, for example. I have also prepared some YouTube links for you where you can take a look at some other examples. It is also well suited for basic and continuous movement. So if you think like imagine you are a plumber and you're on your way to save the princess from this mutant turtle thing. And there are these coins that are rotating around that you have to like collect. Nobody knows why you have to collect the coins, but these coins are rotating. This I would handle, for example, on the world position offset. The disadvantages are there's no collision update because the collision happens on the CPU and the world position offset happens on the GPU. Also, the shadows don't update. Sometimes they do, sometimes they don't, and sometimes they just make weird artifacts. So really know your limits with this. It is not yet usable with nanite meshes, although this will be coming in the future. I think in the next Unreal Engine 5 release, we will have this because I've seen this on Twitter and Twitter is always right. Also, it can be hard to set up. So depending on your background, it may be hard to wrap your head around this at first. And then maybe it works for you, maybe it doesn't. It really depends on what you want to create. Okay, before I go further with the presentation, one more time, make sure if you want to follow along to start up an empty Unreal Engine 5 project and download the static meshes that I have prepared for you with the link inside of the Zoom chat. Okay, quick notes on procedural masks that I have also used. Some of you might already know this. I have also done a quick tech talk about this during the summer of Unreal, but I have gone a little bit further with this inside of this project. So what are procedural masks? I use procedural masks when I'm talking about creating masks inside of a material to mask, for example, the base color or some certain effects inside of a material on top of a mesh without using individual material slots. So within one material, and also without using predefined textures. So you can save on GPU RAM space and also just do the calculation once. Sources for this can be, for example, your UV space, the object bounding box, vertex colors, or the built-in mask functions like the sphere mask, the box mask, and all of that. I just want to give you a few examples and get your head spinning. Maybe I inspire you to do something with this. For the follow along part, I have just created some basic slides for this. We will now start going into the engine and create this for ourselves. I will give you a quick overview of the project, what it can do so far, and then we will start. So let me switch over to the engine. This is my project. I hope you have some similar empty project open for yourself. I will just start the gameplay so you can take a look at this, what you can do. I have prepared my gamepad controller here, and I have now my drone that is flying around. All of this will be blueprint interaction. That is not part of the talk today, but what is part of the talk today is the rotors spinning from this little drone. All of this drone is one static mesh, no bones, nothing. This is all done inside of the material. When I fly around, all of this leaning, this is also blueprint. But now I can fly over this landscape, and you see wherever I fly, the landscape adjusts to it. This is using a sphere mask, so you have this little like diorama effect. Stylistically, it's not great and also not finished, of course. This is just a like tech example at this stage. Also, I have 4 face buttons on my gamepad that I can use to create different effects. So for example, this one spawns a tree. So it shoots a seed out, you might be able to see it. And wherever this seed hits the landscape, a tree spawns and grows up from the surface. This growing animation is also done inside of the material. The trees also have different colors. So not depending on where they are, just randomly assigned colors. This is also done inside of the material, and this is using instance static meshes. So all of these trees are one draw call because it's one instance static mesh. And even though it's one instance static mesh, you can animate them individually only using the material. Some similar but different effects I have created for this tree, for example. This is like a conifer tree that has individual parts that animate one by one. And then I have the palm tree, which I will spawn here. And this has also leaves that when they are spawned, they are animating a little bit inside of the wind. This is also a world position offset. One more thing we can do to reforest this area is to draw grass, which I can do over here. And below my drone now, I will draw grass on this landscape, which is also then animating with the wind. At least it should, yes. And depending where I paint, it will just add this grass. Okay, not a finished game prototype by any means, but just some basic examples that you can put together to create some sort of interactive experience. So that's what we're aiming for. Let me tell you what I've done to create this. I will not start with the drone because this is something a little bit more advanced and complex. So let's start with the most basic one. I will create a new level for this, just a basic level. So if you want to follow along, just create a new basic level. In this level, I will just, in my place actors panel, either from here or just you have it open, just add a cube to my scene, and I will place it at 0, 0, 0, and just put it up 50 so it sits on the ground. It's important that you set it there because we are going to translate it now using the material. To create a material, I have my drone seeds project folder here, and inside of MAT, I have some materials already prepared. Most of them you will get with the download that I will give you after the talk. But for now, I'm going to create a new folder, MOM, Materialverse of Madness, or your mom, I don't know. So open this up and let's create a new material. I'm going to call this M basic world position offset and open this up. Inside of our material graph, we can now see that we have the empty graph that we know and love, and we have this world position offset input. If you hover over this, it also tells you allows for the vertices of a mesh to be manipulated in world space by the material. That's why it was important for us to put the cube at 0, 0, 0 from the world position, because we're going to base our world position offset on that. Let's create a basic color using 3 and left click. Let's make the cube more or less white, but not fully white because that's not physically correct. Just give it some base color because we don't care about color for now. And now I will create the most basic thing I could think of with world position offset. Let's create 2 vector parameters. One will be our start position and one will be our end position. To create the vector parameter, which we will use for this, just press and hold V and left click, and then call this position A. You can also create a vector parameter by typing in vector, but I won't tell you this all of the time because this is a little bit more of an advanced talk. Duplicate this one and rename it to be position B. So we have a second parameter. To animate between them, we can just use a lerp. So hold down L, left click, there's the lerp, and let's connect the two. For the alpha, we will create a scalar parameter and call this animation. Connect this over here and connect this to the world position offset. Okay, create a comment, WPO, and then let's set the parameters up so we can use them in our instance. Position A should be 0, 0, 0, and position B should be the position where we want our cube to move to. We can set this up in the instance later, so that's all fine and well. Just for our animation one, since I know that the lerp only accepts values from 0 to 1, I will just set the slider max to 1, so it's a little easier for me to show you the effect. This is all done. Let's save this and close the material editor down for now. Don't assign the material directly to the cube now. We are going to create an instance of this to be able to control this. So right click, create a material instance, MI basic WPO, and assign this to our cube. All right, let's open this up. I'm going to make this a little bit smaller so we can see this side by side. Okay, should work. You see I have my animation, position A and B parameters now here. If I check my animation parameter and set this to 1, nothing happens because position A and position B are the same. I'm setting this down to 0 back again, and then I'm going to change my position B. And for those of you who now think, wait, B is a color, why should this happen in any way? Colors are also just values. This I will always talk about when you have a material course with me. So colors are also values, and RGB and A, in this case we only care about RGB, can also be X, Y, or Z. And these can be values that define positions, scale, rotations, whatever you need. In this case, we want positions. So I'm going to use the G channel because I'm looking at it from the front. And the G channel, as my green arrow shows me, is the Y axis. if I set this to 250 now, for example, the position B, color, becomes really green. I don't care about the color. I only care about my animation. So if I slide this now over, you see the cube is moving over 250 units. Still, my original location, 0, 0, 50, doesn't change. That's why I wanted it to be 0, 0, 50, because it's easy to remember. So it's just adding to the position in world space. Also, you can see that my gizmo on this cube is still at the original location. So the cube didn't really change place. It's just visual trickery. And that's my first magic trick. So for the collision as well, it will always think of the cube as being still here. It's just showing it to be over here. And now you could do anything you want, set this up to be 250 over here as well. And then you can move it like this. The most basic thing you can do in there. Just create an animation, lerp between two positions, and lerp this over here. I hope this is clear, because this is mostly the basic thing that I've done in the other materials as well. Now we will get a little bit deeper into it, and I will show you some of the examples I have prepared. We won't recreate them step by step. I will show you the finished materials, some of them, and walk you through what I have done there and what part does what. And then we can maybe try to recreate one of them. And maybe I have still time for a little card trick at the end. All right. If you have your static meshes that I have prepared for you downloaded, let's take a look at them first, so we can know what I have prepared for you and why they are the way they are. In this, we have multiple parts for the individual stages of the tree, let's call it that. We have the tree trunk, which is happening completely at the UV space that happens from 0 to 1. Just to reiterate what I mean by UV space, inside of Unreal, if you're using the texture coordinate node, I will talk about this later when we use this, this is a linear gradient in two directions, a two-dimensional gradient, going from 0 to 1 in the x-axis and 0 to 1 in the y-axis. This means all of the UV islands that you have here, which corresponds to polygons and faces in the real static mesh, are assigned a special value, a value between 0 and 1. And you can read out this value using the texture coordinate node. If I now set a mesh up like I have done here, where I have individual parts like the trunk on the UV space from 0 to 1, the next one is in the UV space from 1 to 2, and the next one is from 2 to 3, and so on and so on. You see, I can separate the mesh without having the need for individual material slots, which would increase draw calls. And this is one way of creating a procedural mask. You have to prepare this first on the static mesh side, of course, but that's what I used on this one. The other tree, you can see this here, is just using vertex colors. So let me open this up. I think it's showing this to me here as well, if I show you the UVs. Yeah, correct. But there you see that it goes on over there. Okay, so I'm going to create the tree material now. Before I do this, let me show you what the finished one looks like. So this is the M tree. It also uses world position offset. I will come to this later because I will create a material function with this for you, because this is what we are going to use for all of the other trees as well. You see, I have the base color here that is using a lerp. And in there we have the trunk base color, which is also a parameter, and also the leaf base color, which is blended in here using the vertex color, because I have painted the leaves in red on the vertex color. And this means every vertex that has a red value assigned to it will use these colors. and everything else will use this color. And that's just the most basic thing you can do. And you can author this really easily within Unreal. So you can assign vertex colors or paint them within Unreal. That's really easy. I have created two separate ways to create color variation within this material. I have used the 3-color blend, which just blends 3 colors together that I have gathered from a little color scheme that I've prepared for this. So this only then uses the colors of this color scheme. If you want to use like specific colors, but different for each tree. What this uses is the per instance random node. The per instance random node is used with, like I said, instance static meshes or hierarchical instance static meshes. These are specific static mesh components that you can use within your actors. And for each instance of these actors, of these components, there will be a random value assigned to them. This value will be between 0 and 1. And this means that all of the functions and expressions inside of your material editor that use values between 0 and 1, like these lerps with the alpha value or anything else, you can use this per instance random, just plug it in, and then you have randomness just automatically. The other color variation I have prepared, just to give this as an example for you as well, is using also the per instance random, then remapping this value from 0 to 1 to another value range, which just means instead of 0 and 1, between 0 and 1, it will put out values between minus 0.2 and 0.1. This I'm plugging into a U shift, which just shifts the U of this green color around randomly on a per instance basis. Then I'm doing this one more time, but for a luminosity value. So you changing the color value. If I, let me show this to you. If I have my color picker open here, you have this U value. This U value in this case uses a percentage. So it's also between 0 and 1. And 0 and 1 means all of the colors of the rainbow. So 0 is this color and 1 is this color again. But between this, you see this little rainbow below here. All of these colors happens. So if I am at green and add like minus 0.2, so I go minus 0.2 in this direction, I will get something yellowish. And if I add plus 0.1, I will get something more greenish and go into the blue. That's what happens on the U shift. On the luminosity shift, it will just change the color value. So the lightness and darkness, which also changes the color that you see. Okay, just so you know what this means. I have unplugged this and used this version for my purpose, but you can feel free to play around with this as well once I give you the project. This uses a mask material because you have seen I have created this little sphere mask around everything that then blends everything out that is not within this mask. This is just another material function. And in the world position offset, I have set up a material function that creates this stylized growth. Let me demonstrate to you by going to my landscape map one more time how this looks, and then we can recreate this material function. So if I spawn a tree here, you see it pops up, then overshoots a little bit, and then scales back down. Right? Let me do this one more time. And I can do this also in series, right? So they always pop up and have this stylized effect. Let's recreate this by creating our first material function. I'm going to go over to my material folder now. Feel free to now follow along as well. And right-click under materials. I will create a material function. Let's call that MF Stylized Growth. I will call this O2 because I've created this once already. Double-click to open. I will open my prepared one for me in the background, so I don't tell something weird. So what a material function does, you can see this over here. It just offers you to use an input and then does something within this node, like a blueprint function as well, and gives you then an output that it has calculated. This output is this output result node that you get in your material function. The most basic way to create this growing thing is to use an object position. So right click object position. It's called object position WS for world space. And then use the world position. This translates to the absolute world position. A little bit convoluted, but yeah. The absolute world position gives you the absolute world position of each pixel or each vertex on this mesh. And the object position is more or less the pivot point. And as you have seen, we are scaling always towards the pivot point or from it, since the pivot point for the trees are at the bottom. To create now this effect of growing, you can just subtract this, and then it will scale all of the vertices from this mesh down to its pivot point. If I just plug this in here, let's see if the preview, yeah, it just previews me the values. I can show this to you later in the material. To animate this, to be able to animate this, I can just add a multiply and multiply this value by a value between 0 and 1. So let's create an input, function input. So right click, create input, function input, and then click on this input. Make sure it is from the input type a scalar. We want just to have one value, and set the preview value to be 1. Let's connect this to the multiply and the multiply to the output result. Save this. And then we can create the material itself that will use this world position offset. So let's call this tree basic. So this is the material for our tree. Also, the other trees use this as well. Now open up your content browser one more time, and the MF stylized growth, you can just drag and drop to add this to your material. Now you have this node here. You have the input and the output. Connect the output to the world position offset, and now it shows you an error because it needs an input. Let's put a scalar variable here. Call this growth, if I can type, and connect this up. Stylized growth. I'm just going to give it one more time a color and set the scalar variable also to be a slider max of 1 because I want to be able to slide this around. Save this. And now still the growth is not stylized, but you can see the effect already. Let me go back to this empty level, create a cube again, and create one material instance of this. MI tree basic. I'm going to assign this to my cube. Let's put this up. And now open this up, and I can drag this down here. And you should be able to try this out already. This now scales the cube down to its pivot point. Since the pivot point is at the center, it scales it down to the center. And that's also a really basic effect with just a few nodes. The only thing I have done to create this popping effect is inside of my material function. Before putting the scalar variable in, I'm just using the so-called 3-point levels, which is also a way to remap values within Unreal. So I can put the texture, a scalar variable, in here. Then I have just a few inputs here for the new black, new middle, and new white value. which just means I put in 1 on here. -0.25 and 0. And one more, 0.75. And then put this in here. This will be also part of the final download. So if you don't catch all of the values right now, don't worry. Let's save this. And if I go back, it needs to recalculate shaders because the material function that we have saved now is part of this material. I'm going to open this back up. And once I set this up, it will scale bigger and then scale down to 1. At least it should. So that's basically it for this upscaling effect. I have used this considerably more complex in the conifer tree. Let me open this up for you. In this, I'm using the texture coordinate as a mask. Let me talk about this first before I show you the more complex setup. So as I've talked about, let me show this to you in a on a plane. So here in the preview, I have this plane now. The texture coordinate, if I preview this, shows me this 2-dimensional gradient from 0 to 1 in 2 directions. Since I know that I have set up my UVs for this conifer tree, as I've shown you, in the X direction, where I have the trunk on the 0 to 1 space, and then the individual parts on the 1, 2, 3, 4, and 5 spaces, I will mask this using the component mask in the R channel, which is the X channel. If I start previewing this node, it goes from left to right, 0 to 1, which is black to white. Start previewing. And now, in this case, this is for the color, since I also want the trunk to be a different color than the leaves. And there I'm using an if node, which just compares these two values, A and B. And depending if A is greater than B, or A equals B, or A is smaller than B, you can put in the values, whatever this is. It can be color values, scalar values, anything. Whatever this is, this will be put out as a result. So in this case, I know my trunk is in the 0 to 1 space. So everything that is either equals to 1 on this UV space, or it is smaller than 1, because 0 to 1 should be brown for my trunk, and everything else that is greater than 1, so that is not on the UV space from 0 to 1, should be green. And that's what you can do to use this as a mask for the colors. I've used this more extensively on the individual parts of the tree plopping up. In this case, also, I have used the texture coordinates with the mask for the red channel. And then I have set up multiple if nodes, depending on if the UV space is 1, 2, 3, 4, or 5. And I have just created one growth delay parameter that you can set on a material instance basis as well. And this just gets added to the individual parts using this if node. So this just creates one value depending on the UV space, and then also for these parts. And this value I will feed in using the last if into this here. And this is something we can't recreate within this talk, because the per instance custom data is something that is driven from within the blueprint. And that's what I'm using to animate or set values on a per material, per instance basis from within the blueprint. This will just animate using the time and subtracting this value that I can set from within the blueprint and the and additional like delays that I have added here. This will be subtracted, then multiplied by 2 just to grow a little bit faster, saturated to also clamp it between 0 and 1, and then I've put this into the stylized growth function that we have used as well. As you can see, if we were to build this up from the start, we would sit here still tomorrow, since this is only one of the materials. Okay, if you want to try this out for yourself, just the masking part, no, I don't want to save. Let's create a material for the conifer tree, for example. So right-click Material, M, Conifer, O2, and open this up. To be able to see if this really works, you can also use, instead of these like basic objects, use the tree asset as your preview object in your material. To do this, open up your content browser and navigate to where you have imported your trees. So I have my SM Conifer 01 here. Make sure you have selected it. And then in your preview window, you have this little static mesh icon at the farthest right and the bottom. Click on this, and this will show you now the tree as a preview mesh in your material editor, which is also great if you're creating a material for a specific static mesh, as we are doing. I see the chat is running hot. I'm sorry, I can't look at the chat right now. I will take a look later. All right, so to recreate this, really basic, just create, sorry, not the texture sample, texture coordinate node. And then drag out of there, create a component mask. Then click on the G channel to only use the R channel. Now we have only one channel. And then we'll drag out of there, type in if, or you can also hold down I and left click. This will also create an if node. Now we will compare the A value, which is our texture coordinate UV space, to a value of 1. So create a constant value of 1. And then we can say whatever we want to use here. So let's create two vector 3. Let's set the bottom one to be something like this, something brown for the trunk, and connect this to A smaller than B and A equals B. And then something green for our evergreen leaves, and connect this to A greater B. If you connect now the result to the base color, you should be able to see that your tree is green and your trunk is brown. That's mostly the magic. Let's save this. And now we can get to the more interesting part. As you see, I'm just showing you parts of the materials and recreating some parts of them and more the basics. Feel free to take a look, as I said, at the finished version then and dig around in there. For the drone, I would like to try to recreate part of this with you because I feel it's a really interesting example of this. So if you want, feel free to import your drone mesh that I have prepared for you. It should be as an FBX available to you from the download link. And in this one, if I open this up, you see this little drone. And if you take a look at the UV channels, I have set something weird up because I have some things here on the UV 0 to 1 space, and then something above and to the right side. I've also separated the camera part of the drone. which I haven't used in the game part now, but I'm also able to rotate the camera individually, which will not be part of this talk, but it will be part of the finished project. All right. So to recreate this material, let me just open up the finished one for me. And then we can start creating our own. And this will be something where we'll take some time and try to understand what happens there. M_drone. Okay. Let's open this up. And to be able to see what happens here, I would also suggest to one more time go into your content browser, go to your assets where you have imported your drone, and then select it, and then select this little static mesh icon to be able to preview this. Press F to focus in your preview window. This works as well. And then you should be able to see this drone. I have only separated the propellers, not really all of the propeller parts that should be spinning, since with world position offset, depending on how the mesh is set up, there can also be visual artifacts. And that I don't know if I have included this in the download, that I have done, I have seen on the UV-Packed 1 version of the drone, where some part of the propeller seemed to like slide behind it. This should be fixed and only rotates, like I said, these propeller parts. All right. To rotate something, just the most basic, let's create the rotate about axis node. There are two versions of this. Let me show you the simple one. Then I'm going to talk about why we can't use it. And then we're going to use the correct one. So let's type in here, rotate. Then you should be able to find rotate about axis and then rotate about world axis cheap. Let's select the cheap one for now because we're cheap. This is a material function that is included with Unreal that you can just use. You just pipe in your rotation amount here, where your pivot point should be, and also your world position if you want to change this, because it defaults to the absolute world position. And then you have 3 individual axes that you can pipe into your world position offset. So let's use the Z-axis and put this into the world position. Nothing happens because we haven't set a rotation amount. We could either now create a parameter that we drag around, or we could let someone else do the work for us and create a time node. The time node gives out the time in seconds. And if you pipe this in to the rotation amount, since it is a scalar variable, it should rotate our whole drone around now. If you want to increase or decrease the speed, of course, we can just multiply or divide the time. So let's say I want this to rotate faster. I'm going to create a multiply, pipe the time into the top, and let's set the multiply to be 2, for example, to be twice as fast, and pipe in the result to the rotation amount. Now you see it rotates twice as fast. That's basically it. Since I want this to continuously rotate, I would use the time. And that's also what I would use for the example that I've given before with the rotating coins or collectibles that you have for maybe in your game that are just there rotating around. You can just use the time, pipe this into rotation about world axis cheap, and then this just will continuously rotate. Another way of doing this would be using an actor with the rotating movement component, for example, which is also really easy, but runs on the CPU. And if you have like hundreds of them in your level, then this can be quite performance heavy. And this, if this is instant well, then this can be done pretty well and your performance won't suffer a bit. There's also a video concerning the performance impacts on all of the versions of animating objects. I will give you a link to this after this talk. All right, now we know we can animate, but let me show you why this doesn't work. I will save this now and drag this over here so I can take a look at my level. And there I will drag in my drone static mesh. You don't have to follow along. This is more of showing you our problem. And I will assign my created material to this drone. Drone, you see also, if I hover over it, the preview rotates as well, which is really neat. So let's assign this. And now it rotates, right? And if we imagine this would be only one of the propellers or these rotors, this would work fine. But what about if I rotate this mesh additionally? Normally, if we think about the up axis, the local up axis of the drone, it should now rotate this way. But it still rotates this way because it's rotating on the world axis. And that's why the function is cheap. And that's also why we can't use it for our purposes, because the rotors always need to rotate locally. And now she's spinning out of control. Okay. So that's all fine and good. Let's fix this. Instead of the rotate about world axis cheap, let's right click and type in rotate one more time, and then use the rotate about axis. The cool thing about this is that we can give it a normalized rotation axis, also a rotation angle, pivot point, and position, like this one. But with this axis, we can tell it on which axis it should rotate. For this, let me just delete the rotate world axis cheap. Let's pipe in the time for now. This should work. Yeah. Into the rotation angle. Inside of the normalized rotation axis, we can use the object orientation, which gives us the orientation, like it says, of this object, which is exactly the value that we need. Now we want to also define the axis that we want to rotate on. Right now, we only know how our object is rotated in space, but we also need to tell it on which local axis it should rotate. And this we can do with a 3 vector, which just is x, y, and z. And if we type in a value of 1 in one of them, it will rotate in this axis. Let's say z-axis, because I want to rotate on the z-axis. So let's type in 1 in the B channel. So 0, 0, 1. To combine this now, I will use a rotate vector. Looks like this. And I will rotate this object orientation by this vector, using this as a look at vector. And since this is local, I can now pipe this into my normalized rotation axis. And this should already work. Let's pipe this in, world position offset. It needs the position, world position. And it needs the pivot point. Let's just give it a 3 vector, because we don't care about this for now. Save this. Let's see if I haven't made a mistake. And now it rotates about its local axis. Let me pull this up from the floor maybe, so you can see this even better. If I now rotate this around, it always rotates around its axis. But as you can see, one more problem, it also rotates around this point that I have given it, 0, 0, 0. So we also need to offset the pivot point. And specifically in this case, we need to offset it on the propellers, so on the rotor positions individually. That's why this material is so complex. It's just more work instead of like separating it into individual static meshes. This was a challenge that I thought was interesting to reduce draw calls to a minimum. Okay. Instead of this vector 3 that we have put into the pivot point, just to be able to use this on an object basis, let's use the object position, this one, put this in here, and if I save now, this will work no matter where I put it, as you can see. Because it's always using the object position, which will be the pivot position of this object in world space, as the pivot point where it rotates around, and also the object orientation, in this case, the z-axis, the local z-axis of this object to rotate around. So that's the most basic setup you can do to just rotate an object that always rotates around its local axis. So no matter how you rotate it and set it up in your world, it rotates correctly. And also no matter where you put it positionally. That's all fine and good. Let's stop this for now. Let me just quickly disconnect this so I can show you in this preview. Maybe I'll show you in the static mesh itself. Drone. Turn this up over here. We have talked about the pivot point now, and the pivot point right now is the object's pivot, like the static mesh object's pivot, which is at the center, as you can see here, at the bottom. So the drone sits on the floor, right? So this is the object's pivot point. Since we rotate each rotor around this point, this point, this point, and this point, we need to know where those are, and then tell the object to rotate around this point. Also, we need to be able to tell this to this object for each of these rotors individually without needing it to be separated into individual static meshes. This would be easy if this would be one static mesh, this would be one static mesh, because then the pivot point could be set up to be in the correct space. But no, I thought, let's make it more complicated than it needs to be. Let's see how I have set this up. We're going to create this for one rotor first, and then we can see. As you've seen with the drone UV spaces, I have set this also up in the separate UV spaces. We have 0 for the drone body, then we have 1 for one of the rotors, 2, 3, and 4 for the other rotors, since it is a quadrocopter. So let's create the mask that we have created before using the texture coordinate. A component mask using only the R channel, and then an if node to compare against against this texture coordinate, against the UV space. I'm going to create a constant and compare against 2. Why 2? Because everything that is bigger than 1, or everything that is smaller than 2 can also be bigger than 1. And I have set this up in my final material. Let me pull this over here for a second. That the rotor speed, which uses time multiplied by a speed variable, is one more time multiplied by another texture coordinate mask that I've created, where I say everything that is bigger than 1 should be multiplied by 1, so it rotates, and everything that is smaller than 1 should be multiplied by 0, so it doesn't rotate. That's why I don't care about anything that is smaller than 1, because I have taken care of this over here. We can also first create this and then create a pivot offset, so it works from the start. Okay, so let's go back to our material. Let's set this value to be 1. And then connect this also to the a is greater than b. Create one more constant and connect this to the bottom 2 to be 0. Then pull this over here. And let's give us a bit more space for the time. So the time right now is multiplied by 2 to be able to set the speed. For this, let's create also a scalar parameter. Let's call this rotation speed. Set this to 2 by default. And then I'm going to create one more multiplier to say if this even should be applied by multiplying it with this and piping this in here. Save. If I now reconnect my rotate about axis to the world position offset, you should be able to see that only the rotors are rotating around the drone. So we have successfully created the masks for them. Just on the rotation part. Now we need to create the mask for the pivots. To do this, I'm going to just duplicate part of this. And then, as I said, I'm going to use 2 for the B. And now I have to look at the values because I have measured them before. I'm going to just copy them over. This is A greater, this is A equals and smaller. And now I should be already able to show you this once I set this up. Let me demonstrate this for you in the blueprint. The drone pawn. Here you can see the drone pawn that I've created for this game. And if I take the top perspective, zoom in here, and just create a scene component, and move this close to the rotors. Hello, I want you to move. There we go. So this is more or less the pivot point. And as you can see, it's not perfect. I'm sorry. And these values I can just read out or copy over and then use them inside of my material. So this is 14.7, which you can see, not close, but yeah, more or less. Oh, this is this, yeah, 17.6 and 54. Also not close, but let's call it a day because I know this material works. In this case, I've only set the values up to be 2-dimensional because I don't care about Z. These will only rotate on the Z axis, so the Z offset doesn't matter for the pivot point. It could be -5,000. Let me show you how you can use this as a pivot point before I create all of the other masks, because this is just doing it over and over again. Before we pipe this in, we have to use the object position that we have used over here as well. And we have to add this because the object position, as we know, is, let me close this down, it's just the drone's pivot point, so the origin position. And now we want to add additionally some vectors to displace this pivot point in space. Let's create an add node. And if I add this now over here, this would potentially work. But since this also rotates and could be offset, I need to transform this, transform vector, from local space to world space, since the rotate about axis uses world space. So transform the vector, then add this to the object position, and then pipe in the result into the pivot point. And now you should be able to see that 2 of the rotors are already rotating correctly. And that's all of the magic. The rest is just duplicating the mask a few times, setting up the other pivots, and then we're done. I'm going to do this quickly for all of you who will follow along the little challenge. I'm going to go a little bit faster now, and then we are finished with this. So let me duplicate this. And we use this, this, and this. And A is still mask because we will still compare against the UV space. I have to use the other values here. And set this up to be 3. Now you see the third one is also rotating correctly. Why did I only put in one value? Because the bottom two equals B and is smaller than B are driven from this one, which is also already separating two values. That's how you can chain together multiple if nodes. One more time. Duplicate this, set this up to 4, use the mask, use the pivot, use this result as an input for the bottom two, and then we're done. All right. This is how I have done this. So we have set up a procedural mask using the UV space where we can individually address the subparts of this static mesh, which is in itself only one static mesh. And this is also the case for the conifer tree, where I have set this up that the individual parts plop up one after the other, where I can show you in my materials. This is basically the same thing as I've shown you before with this growth delay. They will go down here and just connect over here through all of the if nodes, only a few more than the drone. So it's basically the same thing, just used in a different context. I will leave this on for you if you want to copy the values for a few seconds. But of course, as I said, you have the finished project afterwards where you can just use them. All right. If we additionally want to rotate the camera, just since we are able to, I can show you how I set this up as well. I will show this to you in the finished version and not build this up from scratch, since we don't have that much time left. The camera rotation is just set up over here. We also use a rotate vector with the object orientation with this one, where we rotate around the x-axis, since the camera, if we take a look here, sorry, has this like pivot point here and can rotate like this, up and down. It also uses a if node to multiply the camera rotation with the UV space, but in this case, we're using the G value because the UV space for this one is above, or I think below, I'm not sure, the 0 to 1 space in the y-axis and not in the x-axis. I could also set this up in the x-axis, doesn't matter, I just wanted to separate, and since we have 2 dimensions available to us, why not use all of them? Then I have just one camera rotation value, that is a scalar parameter, that I can drive with a blueprint, for example, or within the material instance. For the camera position offset, this is just also the pivot point that I've used a special value that I have derived, which is exactly there in the center of the camera. And then I've piped this into the rotate about axis. let me show this to you using the drone here. Set this up here and rotate this. And let's get the MI drone. I think that's this one. I'm going to open this up. This is the material instance now. No, don't want to save this. And let's zoom into the drone. And if I now add the camera rotation here, you see it rotates around. It's a little bit laggy for me now, I'm sorry, but just believe me, it does. And you can take a look, as I said, at the finished one. This uses a value between -1 and 1 because I wanted to be able to rotate it in both directions. 1 equals a value of 360 degrees in rotation in this case. So that's basically it for the drone rotation material. Oh, it's opening up in the wrong desktop. The only thing I've also done is just some color variation using the same if nodes. You can use this, you can't use this enough to create some color separation for the drone body, the rotors, and the camera if you wanted to. Feel free to color this up in any way you choose and dress this up nicely. One more thing that I wanted to show you before I get to my card trick is the palm tree. It just uses a little wind node, which is the simple grass wind. That is a function that is part of Unreal that you can just right click and add simple grass wind. Looks like this. And you can just pipe in some values like here, wind intensity, wind weight, wind speed, and additional world position offset if you wanted to combine this with something. And then I have set this also up to use only on the leaves, to be able to only use this on the leaves. And this then rotates and displaces the leaves around. The same I have done for the grass. The grass is here. You won't see it now because it's also masked by this sphere mask and is also using the stylized growth. But instead of using a value that I give it as an input, I've used a render target. The render target is driven by my blueprints. So if I go back to my landscape map to show you this one more time. Don't save. Not important now. If I look down and now, oh, sorry, now paint, you see that grass gets added wherever I am flying above. And this is painting on a render target that is mapped to the landscape and also colors in the landscape material. And this render target I have also used in my grass. No. Using the local position, divided this by the size of the landscape, masked this to be able to use this as a UV. And this makes it that the render target is used in world space, in a landscape space, basically, on the whole grass object, which is just instant grass used using the grass node within the landscape material. This render target, for those of you who have never seen a render target, you can just create a render target in your content browser, right-click, create a textures render target, or you can also dynamically create one in your blueprint. And as you can see, this is saved from my latest play version, basically. This just paints white onto a black texture. And that is used as white input, which equals 1 in my stylized growth. So all of these individual grass objects pop up one by one based on this texture sample that I input here. To combine these two, the grass wind and the pop-up, I just used an add, and this works completely fine. Additionally, I have used the sphere mask, which I'm going to show you now, to like hide the grass when it's out of sight. And this is also just a really, really basic material function. If you have created a material function and used it within a material, you can always double click to go inside of it. This will open up the material function, and there you can see the mask, this mask that I have set up. The sphere mask in this case is a basic material function that is part of Unreal, where I have set up the world position to be A compared to B, which is the mask position. This is using a material parameter collection, which is inside of my materials as well. Material parameter collection, where I set up one scalar parameter, which is the radius of this sphere mask, and also one vector parameter, which could be a color, but in this case is the mask position. We go back here, and this is what we have here. Since the mask position needs to be the same as this one, I have used the component mask to only put out the R, G, and B values, X, Y, and Z in this case. The same goes for my mask radius, which uses only a scalar parameter. I've only used the R value here to put this into the radius. The hardness is used to define how soft or hard the edge of this mask is. You could also totally set this up within your material directly. I just used the material function to just use one node within my materials, because I have used this in almost all of my materials. And if I wanted to change something, I can always go back and change it inside of the function, and it will be updated in all of my materials automatically, right? That's also one way of using material functions. Okay. Since we're almost like half an hour to the end, let me jump back to my slides now, where I will go through the last slides and then show you one last card trick before we go over to the question and answer session. So here we have now done the follow along part with the basic world position offsets. Then also we have created the drone rotor animation. And now I wanted to talk to you about the next talk that will happen next month. Since I have created this, I thought, why not do a follow-up talk on this, where in the first one, we have created the basic materials, the functions that we use to animate part of this. And then we can put this to use, using the blueprint talk that I will do, where I will talk about creating a little mini game using this drone, where we will learn how to use inputs to be able to control your drone with your gamepad or your keyboard and mouse. So we will set up inputs. We'll use the drone blueprint to make her lean wherever she flies, like a real drone would as well. Also, we will learn how to put in the seed shooting mechanics, drive the material changes on a per instance basis, as I've talked about already, and use a render target to paint grass on the landscape. I will also talk about blueprint basics for a game, like what type of actor classes should you use for what, and how can you communicate with actors in a basic manner and in a more advanced manner. So this could be a follow-up talk. Feel free to also give us feedback on what you want to maybe be covered in this talk. And yeah, this is just an additional offer to you. Before we get to the Q&A session, let me give you one more example of world position offset that I have created. All right. Since I got challenged to do a card trick, since I seem to be the wizard of something, I have created a card material that uses one texture to define all of the cards of a playing deck. And I have created one shuffle parameter that I can use to place these cards in a shuffle position, like a circle around with random rotation. And I can slide this back down to put this back into a deck. Oh, where is it? No, show me the cards. Right, like it's a stack of cards. Was this maybe your card? I can also, if I shuffle this back out, adjust the radius of this circle. So maybe 150. Now it's bigger, 200 or 50. Now it's smaller. Let me show you how I have set this up. This will be just a quick overview. This is also not part of the finished project since it's not part of the drone project, but feel free to ask me anything about this afterwards. Let me open this up big over here. This is also not completely cleaned, but the basic thing, why are you doing this? Okay, ignore the flickering. Let me show you the texture. The texture is just all of these cards, all of the cards that are part of a playing deck in like rows and columns. To use this and create individual cards for each instance, since this is using an instance static mesh as well, in this case as well a hierarchical instance static mesh, it makes no difference in this case, just wanted you to know. I've used the texture coordinate because we know if you want to tile a texture, even if we want to make it bigger instead of smaller, we can use the texture coordinates and multiply it by some value. What did I multiply it by? This seems really random and this seems a little bit not so random. Let's take a look at the texture. We have 1, 2, 3, 4, 13 cards in this axis and 4 in this axis. Since I want to make this bigger, I can't multiply by 13. I have to divide by 13, which means I have typed in 1 divided by 13 because all of these number inputs are also calculators. And this gives me this value. The same goes for 1 divided by 4, which is 0.25. I hope all of you know this. And this now, if I just type this in here, gives me 1 card. What I've done additionally, added to this, offset the UV with this add value. I've used one more time the per instance random, multiplied this by the individual numbers of cards, because I know the per instance random is a number between 0 and 1, and I want to have numbers between 0 and 13 in the x-axis, and then 0 and 4 in the y-axis. Then I have floored them. I could have also sealed them so that I don't have values that are like 12.5 or like 11.25, because I don't want to have half cards. I only want to have full cards. Then I've created a float 2 out of this because I have an x value, which is x, and a y value, which now has one output result, which is a 2-dimensional vector. After this, I can divide this by 13 and 4 again. So I have values between 0 and 1, but these values are exactly with this floor, with these floor values, exactly the values that I need to offset the cards correctly. And that's how I've set this up. One more thing, how I got the idea of a card trick is it uses this two-sided sign, because if you take a look on the back, this now looks completely differently and uses a different texture, even though it's just a plane, and we know a plane has only one face. To be able to use this, of course, you have to activate the two-sided option in your material output. And then you can use the two-sided sign input data on a lerp, which means the A will be the back side and the B will be the front side. At least I think, yeah, it's X, yeah. So the B is this card face, and the A is the back side of the card. So if you look at it from the back, even though it's one-dimensional, or in this case two-dimensional, it will show you the back side of the card. The offset, let's delete this one here. The offset, putting this in a circle, it's just basic math. How do you get the position on a circle? You use the angle by which you want this point to be on the circle, then use the cosine and sine function and put this into the x and y axis. Because I only wanted a two-dimensional circle, I didn't want to displace them in z. And then I've just multiplied this with a radius to be able to like scale this up and bigger and smaller. Let me close this down over here. Then I have just used the z value and created vector 3 because I need x, y, and z for a position. Just use the per instance random, so they are displaced just a little bit. If they are all on the same z axis, they will start z fighting, and we don't want the children fighting. And also, I have used the rotate about world axis sheep to rotate them individually randomly. Then I've created also for the stack, I've created a float 3 with x and y being 0, and the z-axis also using the per instance random, so they are stacked on a like random values, and put this into a lerp in the B, and the circle shape into the A, and the shuffle is the alpha. That's all to my card trick. Sorry if this was confusing at the end. I just wanted to show you one other example of this, and I think now would be a good time to go over to questions and answers. I know the chat seems to be full, so let's see how we're doing this. Let me open up the chat.
No, first, Stephan, thank you. That was fucking crazy.
Yeah, thanks for listening for the start before we go over to the question and answers. Thank you for listening to my Materialverse of madness. I know it seems like madness sometimes. The goal of this talk was really to inspire you to use these effects, these functions to create something for your own. That's why it seemed maybe sometimes a little bit all over the place, because I wanted to include so much. But yeah, feel free now to ask me anything, and yeah, let's see what questions you have for me. Okay, so let me put this foliage tree over here again. And if I open this up, if I open up the tree and show you the UV channels one more time. So imagine this plane, as you see here, this square, is the UV space from 0 to 1 in the x-axis and from 0 to 1 in the y-axis. And this is what the texture coordinate gives me as an input, right? So this is the square 0 to 1. This is where you normally put all your stuff, because you want to be able to have all of your stuff inside of this space. This is where normally the magic happens. In this case, I have put just all of the geometry islands, the UV islands concerning the trunk. All of these are just these little pyramids or cones that I've used for the individual leaf parts that I have offset on a like one space at a time. This is the next one, this is the next one. And so I know that this value on the x-axis, which I'm using on the mask here, with the mask here, which only gives me the x-axis, I know on the trunk it is below 1. Yeah, and that's basically it. Yes, I can still, because textures tile. Textures don't care where you are in UV space. I don't think you can really avoid them, because that's just part of the thing. Let me just reiterate with the basic cube that I have here. And if I assign this material to it, let me undo this shader, the basic world position offset. and open this up over here. No. So if I now slide this over, okay, now the shadow updates because and there you see the shadow issues, right? It should just have this shadow, but it has like this trail behind it. And if I set this to be on 0 on Z, it also leaves it there, as if the cube was also all over there. And there you see it also slides stuff around. So these are the shadow issues I'm talking about. You can get around this. I do not remember the exact option, but this is part of one video that I've talked about that I wanted to share with you as well, where they go into the performance implications of using word position offset versus the other options to rotate an object or to move an object. And you can't really get rid of this. This is really the hardest downfall, I feel, of this option. But if you don't need it, for example, a drone that flies around, you don't care about the shadow of the rotors because basically it's all blur, more or less. But if you want to really move big objects, I wouldn't do this in the world position offset. But that brings me to the point. Let me pull up my links that I've prepared for this. This is one video that just shows these, like on this coin example, how much FPS you can save. I think they use like 300 instances of the same coin, and using blueprint, event tick, rotating movement component, and all of that stuff, they have like 20, 23, 26 FPS, and using instant static meshes and world position offset, they have 120 FPS, almost no performance, no performance hit whatsoever. So that's one of the videos. Let me paste that in the chat. Another one is whether they have shown this using this instead of a skeleton mesh, like for a fly, a butterfly. I've shown this example as well in some of my trainings with a butterfly, where you can also increase FPS for non-essential animations like this. And a more advanced example of world position offset is this one. This is a video by Unreal Engine where they talk about simulating large crowds inside of Niagara, but also world position offset is part of this. Let me show you what part it takes here. So they have these birds. All of these birds are Niagara particles, and all of these birds are static meshes. These birds use vertex animation, and they show this here. They have a great talk on this, so feel free to take a look at the video. They use for this vertex animation textures. So here he shows the diffuse texture. You shouldn't name this diffuse because it's not physically based. But here they show the vertex animation, where they use individual rows, pixel rows and columns for the individual vertices of the static mesh. And then based on the color values that you have, R, G, and B for X, Y, and Z, you can then displace this in space. And there are also tools to bake this down, to bake animation data into these textures that you can then use on static meshes, which is a huge performance improvement. This is also done, I think, if I'm not mistaken, in the Matrix Awakens demo for the really far away, like artificial intelligence, AI people. Yeah, I think it would be possible because all of the vertex animation texture data is also just values that you can do math on inside of your materials. You are limited by the material functions and options that the material offers you. So you can't do loops, for example, as far as I know, inside of materials, although I heard it should come. But basically, yes, you can, like if you find a way to individually address all of the slices that are part of your animation texture, you can start to retime this, or anyway, maybe it's also part of a function that you build for the animation of the animation texture. This should be possible, yes, but this might be rather advanced. Yeah, of course. Let me show this to you in a basic example. here over in Blender because it's easier for me to do this here. I'm going to add a cube. This is just a basic object. And if I go over to UVs, you see on the left side the UV space of the cube. And on the right side, you see the 3D representation of the cube. The UV space, as we have learned, is a space from 0 to 1 in 2 axes. So it's 2-dimensional. And what the UV space does, or what the UV does, is that it lays out all of the 3-dimensional geometry onto a flat, like a table, as if you were to cut up like my shirt and put this flat on a table. Then you can imagine painting on this flat surface. This is what a texture then does. And wherever these faces that correspond to these faces on the 3D object are, this part of the texture will be applied to this part of the geometry. You can create UVs in Unreal. I'm not sure if you can move them like I have done of the UV 0 to 1 space. I don't think that's possible. Modeling, and then inside of modeling, you have the UVs down here. You can automatically UV, unwrap, project, seam edit. There are some options down here. Okay, so yeah, thank you for watching. Thank you for listening. Thank you for just being here and listening to me. I hope you have a great evening or whatever time of day you have on your side of the world. And yeah, see you maybe in the next talk.